Hello. Hello. My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the SAT. We have been solving math problems and the grammar questions out of this book here, the official SAT study guide, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. In case you're curious about what I said about the grammar questions, you can just type in SAT Grammar Day 1 and it will pop right up. And you will find the grammar videos that I have there on the YouTube. One more time, SAT Grammar Day 1 and so forth. Number 19 is what we're going to do. Number 19 is obviously one of the last two in the section. It is a difficult question. It is what the College Board calls a level 5 question. Well, let's take a look at it, see what he has to say. They give you a picture here, so my first job is to reproduce the picture on the blackboard. I will do the best I can and we'll see how it comes out. Sometimes they don't come out right, so I have to redraw it. So redraw them, so we'll see what happens. So here's the picture. It looks Here's our pyramid. Here's the center of the thing, and they drop a perpendicular. And that perpendicular here, this is the V for vertex, this perpendicular here has a height h, and our job is to find that height. So essentially what we're interested in is this triangle. This triangle right here. Let's give it a name instead of saying this triangle and that triangle. Let's give everything a name. So I'm going to start from here, giving the names to these four vertices, A, B, C, and D. A, B, C, and D that we just plotted is the base of the thing. Is the base of the thing in Babur, the pyramid. A, B, C, and D. And they're asking for the height. They're asking for the height, and here's the triangle. Let's call this thing W. V, W. So the triangle that we're interested in is VWC. I'm going to put it here, right here. VW. This is the vertex right here. Vertex. And then there is a W. And that's your C. This is the right angle. How do we know this is the right angle? Listen carefully, please. How do we know this is the right angle? This angle right here. How do we know that this is going to be a right angle? Very simple. Because this line, this point here is a W, it goes straight to that edge there. It's a straight line. It's a straight flat line, and they tell you that h is the altitude. If you read the question properly, it tells you that it's the altitude. Altitude is another way, a fancy way of saying perpendicular, the height. And how does one measure height? One comes straight down, one drops a perpendicular. So if this is a perpendicular, V to W is a perpendicular, that means it's coming down straight. This is a flat line, W to C. This makes a right angle. And they want to find out, they're asking us, what is this edge? This is the question mark. What is this edge? Well, we already know how much this is. V to C, they tell you, is E. And they tell you the side of each of these is M. All of these are M. The base of the pyramid, let me read the question as they give us. It says the pyramid shown above has the altitude h, which we just showed here, altitude h. And a square base of side M. A square base of side M. This is the base of the pyramid. This is the base. I was going to write the base in it, but then I realized I need the room. The four edges that meet at V, the vertex of the pyramid, each have the length E. Right here, each has the length E. In other words, V to C is E, V to D is E, V to A is E. V to A equals V to B, which equals V to C, which equals V to D, and they all equal E, which we are told also equals M. Now where is V to B? I am not shown here, V to B, but there is a V to B in the back here. It shows in the picture there. I'm not going to put it here because I don't want to make it too crowded. But if you'll see, the right here, V, this point, if you were to join a line V to B, that's another one, and it's the same length. V to B is the same length as V to D. Because of the fact that it's three-dimensional, of course they look different because it's in the background. Anyway, you get the idea. Our first job, in order for us to find the height, we need to know what this base is. We already know what this is. They're telling us this is E, which is same as M. So this is a known quantity. We can use a simple Pythagorean theorem and figure out the h if we can somehow establish what W to C is. W to C is right here. W to C is right here, which is half the diameter. Half the diagonal. So we're going to figure out the whole diagonal. We're going to figure out the entire diagonal. Let's call it D. This is right angle. This is M. This is M. So we're going to use the triangle ACD. In triangle ACD, the diagonal, which is the hypotenuse, which is D squared, equals this side squared plus that side squared. A simple application of Pythagorean theorem. So that's 2m squared equals your diameter squared. Why do I keep calling it diameter? There is no bloody diameter, it's a diagonal. And therefore, if you take the square root of both sides, the diagonal D equals the square root of 2 times m. But we are only interested in half of it. We are interested in from this point to this point here. We are only interested in half the diagonal, because the half the diagonal right here, half the diagonal D over 2 is the base of the triangle right here, if you see it. So let's take a half of that, divide this side by 2 and divide this side by 2, and that's it. This is our quantity. We're going to put that in here. Half of the diagonal equals this quantity right here, root 2 times m over 2. This is it. I'm going to leave it there. Don't mess with it. Just leave it there. When the time comes, we'll simplify it. For the time being, just leave it there. That's it. We're done with this triangle. Now we're going to move on to the new triangle, which is WVWC, and figure out this height. That's it. We already know this side, W to C. We already know what that is. We're going to figure out the other one. Okay? So let's do it then. I need the room, so I need to erase all of this thing. We're done with triangle ACD. Finish. Now we're going to work on this triangle. It's a hard question, it's a level 5 question, but ironically, even though it's a level 5, all it requires is 2 simple application of Pythagorean theorem. That's all it is. You have to apply Pythagorean theorem twice and you're done. We already did it once. We did Pythagorean theorem once in the triangle ACD. We're going to apply it again in the triangle VWC. In triangle VWC, again same thing. Here's your hypotenuse, which is m. M squared equals the height squared, which is our unknown. We want to find that height, and plus this squared. Root 2 times m, root 2 times m over 2, and we're going to square this whole thing. That's what Pythagorean theorem is. C squared equals a squared plus b squared. This is your a squared and b squared. We'll simplify it. H squared equals square of root 2 is just 2. M squared is m squared, and then 2 squared is 4, which boils down to 1 over 2 squared. Bring this quantity on this side, so h squared equals m squared minus this quantity right here, which we just found out is half m squared. M squared minus half m squared is just half an m squared. That's it, we're almost there. Now take the square root of both sides. This is your h squared. Let's take a square root of both sides. And that gives us square root of m squared, of course, is m, which is this quantity. And at the bottom we have square root of 2. That's it. This is our h. This is our height. That's it. We're done. Let's keep it separate here. Put a demarcation here. And if you do not know the word that I just used, demarcation, learn it. It does not hurt to improve the vocabulary at the same time. And if you're interested, you can do so by watching the vocabulary videos that I put together on the YouTube. And demarcation was a word that I believe I covered on day number, I will tell you when I believe I covered it after I find out exactly, day 12. Demarcation is just a fancy way of saying a boundary, a border. Let's put a demarcation here so we can keep the two separate. That's it, we're done. This is our answer. So just type in vocabulary. Vocabulary, day 12, and it will pop right up. Watch the video and learn the word. I want you to absorb this thing for about 15 seconds. Just look at the screen and absorb it. I'm going to be right back, and I'm going to show you a visual aid to this problem that I happen to come across, and inadvertently I left it in the other room. Give me about 10-15 seconds. I will run right back, and I'm going to show you exactly what we're dealing with here. What it is watch this. Watch here. This side, B to A is your M. B to A is also M. B to A is also M. And A to D is also M. It does not look like it, but this triangle BAD is in fact an equilateral triangle. So is this one. BDC is an equilateral triangle because this is E, which equals to M. Okay, watch here. B to C is M, C to D is M, and V to D is M. Therefore, VCD, this triangle here, it does not look like it, but it's an equilateral triangle. I'm going to show you that visually, and then I'm going to add one more comment to it before I end the video. As I said, give me 10 seconds if you're interested, 10 to 15 seconds, and you will find it fruitful. I'm going to end this. The part that I'm doing right now is not necessary as far as the problem is concerned. We have long done. I'm going to show you the visual aid. Watch what happens. Here is the base of my pyramid. As you can see, it's a square base. Just put it here so that you can see it. Here's my base. Here is the equilateral triangle I'm talking about. Three sides are equal, and this side, each side of this triangle is the same length. Is the same length as the side of the base right here, as you can see, right there. And then you put four of them together, and you make a small pyramid right there. And I'm going to put the fourth one, as you can see. I'm going to put the fourth one. Voila! There is your pyramid. And the question was, how much is the height of this pyramid? Listen very carefully. And what we found in this problem, and I'm going to make a note of it someplace prominent. I need the room to write what I'm about to write, so I'm going to erase this part. We're done with this thing. We don't need it anymore. What we found is that if the pyramid has a square base of the same length as the length of the side of these sides, in that case what we found, as you can see, the base M is the same length as this one. And what we found is that if that's the case, then the height of the pyramid happens to be half the diagonal. Diagonal is from here to here, and whatever the length of this diagonal is, half of that length is the height of this pyramid that I'm holding in my hand. That's it. The height of this pyramid is half the length of the side of sides of its base. There it is. One more time. That's all. That's all there is. I don't want to beat the dead horse. That's it. We're done. I will see you tomorrow when we'll do problem number 20. Okay? Bye now.